Okay, so Alicia and Clara had a total of 764 bits. They each used some of their bits to make a necklace each and keep their remaining bits. Okay, so do you realize that they say that they each use some of their bits to make a necklace each, but they did not say that the number of bits needed to make each necklace is the same. So if they never say it, most likely or not, it is more probable that each necklace uses different number of bits. They are not the same. Okay. Now, so they said they use some of the bits to make the necklace each and keep the remaining bits, right? Then they said that Alicia had 1/3 as many bits remaining after making the necklace compared to Clara, alright? And then number of bits that Clara used to make her necklace was 63 more than what she had left. Okay, so that's the next information. Followed by Clara used 3 times as many bits as Alicia to make her necklace. There we go. Number of bits for each necklace for each person is not the same. Then the question is, how many bits were used to make the 2 necklaces? How many bits did Alicia have at first? Do you realize that every single time I teach the longer problem sums, I will spend a lot of time on the information here, but I'll just breeze through the question. The reason being that I'm not even interested in the question at this point of time. I'm more interested in making sense of this. You need to make sense of it. You need to understand this, draw a model, visualize the entire question here before you even look at the question. Why? It's because there are many students, and for parents who are watching this, many of your kids, they will be so intimidated by the mass of words over here that they run to the question for comfort. Okay? So they quickly go and read the question as if this is going to give them some guiding post. No, tell them stop it, don't do it. Okay, internalize, visualize this question before even reading a question. Trust me, that is a lot better for their self-esteem and their confidence level. Okay, let's go step by step. So I know that Alicia and Clara, they both had a total of 764, blah blah blah. Then use some of their bits to make a necklace each. And then after that, at least Alicia had 1/3 as many bits remaining. Okay, so there's a before and after, right? Before is when they hadn't made the necklace yet. After is what is left after they have made the necklace. So as per usual, like what I told you previously, always go and draw the after first. So after that, Alicia had 1/3 as many, right? Okay. So I will draw Alicia. Alicia is 1/3 as many, so Alicia will be 1 bar. Okay, and Clara, so remember the starting line. This one would be 3 bars. So 1, 2, and 3. This is what's remaining, right? Okay, so usually if it's a long question, after I denote something from the passage to the model, I will just take it. So this one, Alicia, I wanted as many bits remaining, so this is the remaining, right? So I already put that inside my model, so I'm just going to take it. To remind myself, I'm done with this. Okay. Then they said that, okay, this one is the number of bits that Clara used to make her necklace was 63 more than what she had left. See, the number of bits that Clara used to make a necklace was 63 more than what she had left. Which means that, okay, so I'm going to put Clara R. What does it stand for? It stands for Clara remaining number of bits. And then this one will just be Alicia remaining number of bits. Okay, so I'm going to put Clara N, which is the number of bits she used for the necklace. So she said that, the passage states that the number of bits that Clara used to make her necklace was 63 more than what she had left. So I have to draw another bar which is longer than this bar. Okay, so let's just go ahead and get it done. So drawing this. Okay, and then this one is the comparison line, right? So always draw comparison line. It's really good for you. So this is 63. Okay, so I'm done with this, so I'm going to take this. I'm done. Then they said that Clara used 3 times as many bits as Alicia to make her necklace. So I'm going to divide this entire thing into 3 portions. Okay, okay, so once I've divided this, then here I'm going to put Alicia necklace. Okay, and the number of bits that Alicia used to make a necklace is 1/3 of Clara, because Clara used 3 times as many, right? So again, I'm going to draw the comparison line very clearly, denoting the number of bits that Alicia used. Okay, so this one is this. Okay, so this one is like that. So which means that right now we have a comparison between this, and this, and this. which are the same. This, and this, they are the same. Whereas this, and this, they are the same. Okay, so it can be a bit tricky, it can be a little bit difficult, so but don't worry, it's all gonna be alright. So this one done, right? Okay, then they said that there's a total of 764. Do you all notice that even at this point of time, I didn't even bother reading the question yet? Because there is no need to read the question if you can't even visualize and understand the question. Seriously, there's no point. You're just gonna make yourself feel a lot worse about yourself. Okay, so right now, I'm gonna show you all something. So these are the small ones, right? Okay, so you realize I'm gonna put small. These are the small bars. These are the small bars, and they are the same. All the SS, they are all the same. Then the remaining ones, right? Sorry, the one that they used to make a necklace, I'm gonna call them the long bar. So L, 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 L. Okay. Now, do you realize that this entire thing, L plus L plus L, is 63 more than S plus S plus S? So only with a model can you actually see this. I know that 3L together is 63 more than 3S. Now what I need to do is to find out the difference between 1L and 1S. Okay, 1L and 1S, which means that what I'm trying to find this. I'm trying to find the difference between 1L and 1S. Okay, because once you can find the difference, you can do a lot of things with this. Since 3L and 3S, the difference is 63. The difference between 1S and 1L should be 63 divided by 3. Okay, so I'm just going to go ahead and do this. 63 divided by 3, that will give us 21. This tells me that one long bar is 21 more than one short bar. Okay, so after doing this, I'm going to convert all the long bars to short bars right now. So, which means that this is 21. Okay, because this long bar is 21 more than a short bar. Okay, so I'm going to, after I convert this, right, this will no longer be L. This will be an S. Okay, this one is same thing. So I'm going to convert this into 21, and this will no longer be L, this will be a S. So all this will be the same thing. 21, this is S, this is S, and this is 21. Okay, so I'm going to help you all to see a lot clearer. Give me a second. Okay, let me just make it sharper, make the image sharper for you guys. Okay, I hope this is better for you all. Okay, so what I did was I converted all the long bars into short bars and 21. Okay, now that we have done this, the entire thing is very easy because we have 1S, 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 and 4 sets of 21, and the total is 764. Okay, why we need to draw a model is because we want to ensure that all the units are the same. Once all the units are the same size, we can then now do division. If it's between short one and long one, that you cannot do any division. They will not be accurate. Now that they're all the same, now we can do. We have to count how many short bars are there. 1, 2, 3, 4, 5, 6, 7, 8. 8 short bar plus 4 sets of 21 give us 764. Okay, which means that 1, 2, 3, 4, 5, 6, 7, 8. 8 short bars. I'm going to put 8S. Okay, or you can put units, it's the same thing, doesn't matter. Is equal to 764 minus 4 sets of 21. Okay, so that will give us 764 minus 4 times 21 is 84. Okay, 764 minus 84, that will give us 680. So we have to find one unit first, and one unit will be 680 divided by 8. Okay, so do your long division. 680 divided by 8, this will be 864, 4, 5, this will be 85. So each small bar will be 85. With all this in mind, you can now solve the question very fast. Now they say how many bits were used to make the 2 necklaces. So remember, N is for number of bits used for necklace, right? R is for remaining number of bits. So let's see, for Alicia, she used one small bar, which is 85 and 21. And then for Clara, she used 3 small bar and 3 sets of 21. See, you can do it immediately. You don't even need to do any complicated working. Now, so for part A, usually this is what I like to do. How I like to present my answer. The first part over here doesn't relate to the question at all. I mean, it doesn't relate to question A nor B. So I will only label A from here onwards. It's because it's only from here onwards that I'm doing part A. Okay, so number of bits used by Alicia. So I'm going to put number of bits used by Alicia, arrow, will be 1s, which is 85, plus 21. That will give us 106. Now, next one will be number of bits used by Clara. So number of bits used by Clara would be 3 sets of short bar plus 3 sets of 21. So it's 3 times short bar plus 3 sets of 21. Okay, giving us 3 times 85, that would be 255, plus 3 times 21 would be 63. So in total, 45, 18, 318. Okay, so 318. So in total, the question is asking for how many bits were used to make the 2 necklaces, right? So what's the total? Total will be this 106 plus 318, giving us a grand total of 424. This is your answer. Okay, so this is the groundwork that you lay. This is the basic math, the one that you're trying to do, the working you're trying to do in order to make sense of the model. Once you have done this step, you can answer all the questions very fast, very easily. But if you were to skip this step, the type of working you're going to have will be a crazy amount, and most likely or not, you are probably going to get it wrong, okay, if you're not careful. So please spend some time to use the model. It's great for you. Okay, so we are done with A. So then next, now deal with B. They say, how many bits did Alicia have at first? Now this is very simple, right? Because for Alicia, she had 1s, 2s, and 21, and this is her total. And we know that 1s is 1 unit, right? Which is 85. So it's 2 times 85 plus a 21. They will give us 170 plus 21, giving us 191. Simple. Okay, done. Easy. Okay, so I hope you all use this method. For parents who are watching this is actually quite a tricky question, honestly. It's not just about the content of the question. It's about human psychology as well. If you were to read something so long, and for students, some of them, they will tend to skip information, which means that some of the kids, they may read the first line, they will quickly browse through the second line and read the third line carefully, and quickly browse through the fourth line, and quickly browse through the last line and skip to the question. Now think about it. This is not an easy question. If they were to read this line carefully and skip this line and read this line carefully and skip the next 2 lines, how are they going to understand the question? There's no way, right? So for human psychology, we have to train our own kids. We have to train our own students to see how to help them to understand part by part, which is why we draw the model. Which is why most of the time I'll teach you all, draw the rough model first. After you draw the rough model, then try to input as much information inside as possible after you've done each part of the working. After that, convert each of the model, because just now we have the short bar and the long bar, right? So convert all of them to be the same. After you converted each of them to be the same, that's why you can do this. And then you can divide by 8. If they are of different length, how are you going to divide by 8? You can't do it, right? So these are all the strategies needed to answer questions like this, to tackle very long fraction problem sums, which a lot of students, they find it very challenging to do. Okay, so this will split the stronger students from the weaker students, and I hope that you all can benefit from this video. Alright, done.